As you can see, I am out again today. My daughter is still sick, but I should be back on Monday. I wanted to make you guys a video anyway. So anyway, sorry that you guys can probably hear Blue's Clues in the background, but this is the best that I can do. Um, we're going to be writing equations from transformations. And again, somebody might want to sit at my desk and pause this video periodically because I'm not going to give you time to write stuff down. So somebody might want to sit there to pause it. You have done these before, but you did them for all parent functions, and now we're doing them just for absolute values. So the first thing it says is to shift it up 3. That means that we're going to add 3 to the very, very end. And then it says to go left 4. Now remember that left and right are your x's, and x's lie. So left you would normally think minus because that's towards the negative numbers, but we're going to add 4. So our new equation will be y equals the absolute value of x and then plus 4. And then at the, oops. Sorry. And then at the very, very end, you add 3. So that's where I got those numbers from. That's why I am color coding. Reflecting across the x-axis adds a negative to the front. If it's shifting right 3, that means that the left and right, of course, x's, they lie. So right, you would normally think plus, but in this case, we're minusing 6. And then up and down are your y's. You just add or subtract those at the end. And since we're going down 2, we're going to subtract 2. So we have y equals. And then that negative goes up front. The absolute value of x. And then minus 6. And then minus 2 at the end. So my blue reflects across the x. My red shifts it right 6. And my green shifts it down 2. For the next one, we're reflecting across the x-axis, so that's still a negative up front. We're going to stretch by a factor of 3, so that means that we're going to put a 3 up front. We're going to shift it left 4, and remember left and right are x's, x's lie, and left means that we're going to add instead of subtract 4. Sorry. And then you will go down 1. So that means that we're going to subtract 1 at the very, very end. So we have y equals, and then a negative up at the front. And then a 3 along with it, because the stretches always go up front. The absolute value of x. And then it's going to move left 4, so plus 4. And then it will shift down 1, so subtract 1 at the end. The next one, we are going to shrink by a factor of 0.5, which means that we're going to put a half up front, or 0.5, whichever one. And then we're going to shift it down 4, so that means that we're going to subtract 4 onto the end. So y is equal to 1/2 or 0.5, the absolute value of x, and then minus 4 at the very, very end. And the next one, it's going to stretch by a factor of 2, so 2 up front. Shift right 3, those are my x's, so we're actually going to subtract 3 instead of add. And then down 6, so that means that we're going to subtract 6 at the very, very end. So y equals, and then up front will be a 2. The absolute value of x minus 3, close your absolute value bars, and then minus 6 at the end. The next one we are shifting down 5, so we're going to subtract 5 at the very, very end. And then left 2, whenever we move left, we're actually adding 2. So y is equal to the absolute value of x plus 2, and then minus 5 at the end. Okay. Whenever you're given graphs, you first need to see what your parent function looks like. So, of course, my parent function would look like this. It has a slope of 1, so it goes up 1, right 1. So corner to corner, up 1, right 1. Okay, that is my parent function. So first, I moved left 1, 2, 3, 4, 5, 6. So since I moved left 6, that means that we are going to add 6. And then I went up 1, 2, 3. So we went up 3. And if you can see, it is upside down, so it was also reflected. So that means that our equation will be y equals a negative up front, absolute value of x plus 6, and then a plus 3 at the end. Okay, so over here, let's draw our parent function. So if you see a big visual difference in this one, it's because this slope is different. So see, in our parent function, we went up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. Well, in our function we're given, we're actually going up 2, right 1, up 2, right 1, up 2, right 1. So that means that we're going to multiply by 2 in the front. From this vertex, it also moved left 1, so we're going to add 1. And then it went down 1, 2, so it subtracted 2. Sorry for the coughing. It's not like y'all aren't used to it by now, though. So y equals 2 up front, the absolute value of x plus 1, and then we subtract 2 on the end. And that's that one. Lastly, we've got to do some word problems, which everybody loves. I know that part of this word problem is hanging off the page. I apologize for that. But you guys can always read it on yours. It says a publisher packs an average of 250 books in each box. The number of books a box can vary at most by 5. If the cost of each book is $5, what is the range of the possible costs? So we're gonna be looking at the costs. They're gonna have to be less than or equal to, and a high number and a low number. So first, we still have 250 that are supposed to be in each box, but it says that it can vary by a factor of 5. So 250 books in each box, but it can vary by a factor of 5, which means you could add or subtract 5 from that box, and that's still within an acceptable range of books in the box. Because whenever we use machines and things, it doesn't always get things exactly right. So we always say that there is a certain variance that is acceptable. So this one says that it can vary by 5. So in one situations we are adding 5 to C, which gives us 255. And then in the other situation we are subtracting 5, which gives us 245. Now, this would be our high and our low if they were just asking for how many books, but what they're actually asking for is the cost of these books. So, and it says that the cost is $5. So we're going to be multiplying each of these numbers by 5. So this is 5 times 5, 25, 25, 26, 27, 1275. And then we multiply this one times 5. 22. So 1225. So our low number is 1225. And then and that is dollars. And our high number is 1275. And that is our answer whenever they ask for a range. The next one says a steel rod produced at a factory must be 10 inches in length with a tolerance of 0.2 inches. Steel rods that are not within the tolerated lengths must be thrown away. Which of the following inequalities can be used to assess which steel rods are tolerable, if L is the length of the rod? Okay, so the thing that it must be is 10 inches. So we know that it's going to be the absolute value of L minus 10, no matter what. So we can automatically take off these top two. We know those are not right, because 10 inches is what it has to be. Then it says that the tolerance of 0.2 inches, which means that it cannot go above 10.2 or below 9.8. So it has to be less than or equal to 0.2. Has to be. So that is our answer, which is this one right here. And it will always be, at least most of the time, the majority of the time, be less than or equal to. I don't like to say always, but most of the time, it will be less than or equal to. The last one, it says a type of mobile phone produced by Nokia must be less than 8 ounces in weight with a tolerance of 0.3 ounces. The mobiles that are not within the tolerated weight must be recycled. Which of the following inequalities can be used to assess which mobiles are tolerable? W is the weight. So the thing that it has to be, it tells you right here, has to be 8 ounces or less. So that means absolute value of W minus 8. So we know we can automatically take off the top ones. And then the tolerance has to be less than or equal to 0.3. So we know that it is this one. And that one's not it. You guys work through day 3 of your packet and be good for your sub. I'll see you guys on Monday. Have a great weekend.